But now I want to give a brief introduction about my research. And today my topic is about the preparation and application of sustainable green quantum dots. Okay. Recently my lab worked on the quantum dot, and quantum dot is actually very popular recently because quantum dot is also kind of a nanomaterial, but the size is even smaller. Usually the quantum dots, the diameter is only just few nanometer in size, and because the size of quantum dots is even smaller, so there is something more interesting characteristics comparing to the bulk material or narrow material. But however, the quantum dots in the previous studies, most of quantum dots are semiconductor quantum dots. Therefore, they are toxic, and during the preparation, they have to use some air sensitive chemicals and expensive chemicals. And as I mentioned earlier, they are mostly toxic. Therefore, the scientists are always want to discover some new material for the preparation of quantum dot. Therefore, in the 2004, there's a new series of carbon material which is called carbon quantum dot is synthesized, and because carbon there are so many carbon in our Earth, therefore carbon is kind of non-toxic material comparing to the semiconductor materials, and therefore the application of quantum dot just be boosted in the recent year. And as you can see in this slide, there are so many application of carbon dots, including solar cell, drug delivery in the contrast agent and so on, even the energy storage device. Okay, and this is quantum dots, especially carbon quantum dot. But however, because if we use the lab chemical or standard chemical to prepare the carbon quantum dot, you eventually, or we have to waste the source of our lab, and therefore in the more recently, people are trying to use the some green source to prepare carbon quantum dots. Which means, if, for example, in the campus, sometimes we can always see some leaves or some bio waste, or when we finish our lunch or our dinner, there's always some waste, and those waste are all contain carbon, and therefore, so in more recently, there are so many groups, they are trying to convert those waste to be the precursor of the carbon quantum dots. And as you can see in this slide, there are so many applications using the biomass or using the waste, such as coffee grounds, orange juice, banana peel, soy milk, rose flowers, and so on. And when we use this natural precursor to prepare carbon quantum dots, and one of the most important advantage is they are inexpensive, and those precursors are high abundance, and that's the reason there are so many studies. They are trying to use the natural products as the precursor, although they have some limitation, because, for example, if I want to produce carbon quantum dots using apple, but different areas of apple, the contents, for example, the content, for example, the sugar in the apples are different, or the ascorbic acid in the apple are different. So sometimes they will restrict the reproducibility of the of the carbon quantum dot. But anyway, it's still very interesting. And in our lab, we also try to prepare some different green quantum dots, and we try to prepare the iron oxide quantum dot. Although iron oxide is metal oxide, but comparing to the semiconductor quantum dots, it is also less toxic. And more importantly is iron oxide quantum dots. It can be magnetic. So this very fascinating. So in the recent years, our lab are trying to prepare carbon quantum dots and iron oxide quantum dots, and we also want to apply them in different applications. And so in our lab, we apply them into the sensing application and frozen ink, even the wastewater treatment. So I want to share you some of our results. And first of all, I want to introduce with our quantum dots can be applied as the metal ion sensor, because the quantum dots are frozen, especially the carbon quantum dot and the iron oxide quantum dot synthesized in our lab. They are all frozen. And because of the different functional group on the surface of quantum dots, they are capable of interacting with different analytes. So we can apply them into different sensing application. For example, we use the cranberry as the precursor. We synthesize carbon quantum dots, and we found that when we use cranberry as the precursor, the synthesized carbon quantum dot, they will have spatial in or high affinity with ferric ion, and the fluorescence will be quenched. Therefore, we can use it to sense the ferric ion in the aqueous solution. And we also try to use different. So for example, this is the straw mushroom, which is very common in Taiwan. And we use this straw mushroom as the precursor to synthesize carbon dots. And we found that when we use that as the precursor, it can interact with ferric ion and lead ion. And therefore we can also fabricate as the fluorescence sensor. And we also use the different precursor, especially I prefer Taiwanese fruits. As we can see, we use star fruits, and we use that as to synthesize carbon dots to fabricate the organic dye sensor. And other than organic dye, we also fabricate the quantum dots to sense nitroarene, which is also one of the important organic waste in the industries. Okay, and other than those applications, we also try to use iron oxide quantum dot for food analysis. Therefore, we in last year we use the iron oxide quantum dots for lysine sensing in dairy products, which is yogurt and milk. And also we use different paving agent to synthesize iron oxide quantum dots and to use in pharmaceutical sensing. And this is the tetracycline, which is one of the important antibiotics, especially in COVID-19 situation. Okay, and other than sensing application, the quantum dot synthesized in our lab also used in different applications. For example, in this slide, as you can see, we use carbon dots as the fluorescence ink, which is can be used in different applications or just this one. The quantum dots, during the preparation of quantum dots, there's also some waste, and we keep these waste and use them as the absorbent for wastewater treatment. As you can see in this slide, the biomass can be used as a very efficient organic dye absorbent. Okay? And we also try to combine the quantum dots with different application, but due to the limitation of time, so I will skip this slide. And so in conclusion, in our lab, we synthesize different novel green quantum dots, including carbon dots and iron oxide quantum dots, and we can found they can apply in different application, including sensing and in even the wastewater treatment, and the other possible application are also under study. Okay, and I think that will be all for my introduction today. But anyway, thank you for your listening. Thanks a lot.